Hello, everyone. So as Julia mentioned, this online interface is an interface for PyWR. So in the background, there's PyWR. To start using the interface, you need to create an account. And I think a few of you already went through that process. But simply to start using the system, you need to log in, put in your credentials, and then it will get you right into your workplace where you can see your project. Apologies if my internet is a little bit slow today. So here, this is the first page that I see when I log in. It contains quite a number of projects because I'm working on different projects now. But in your case, if you are new to the system, you'll probably not see any project there. Or perhaps you'll see only one demo project. Yeah, but in my case, I'm working on a number of projects, and a project in this web interface is just a way to organize your models. So each project can contain a number of models, and a model here is called a network. So for instance, this project of Volta models contains 12 networks, so there are 12 versions of this model inside. If you hover over one of these projects here, over this crowd of people, you can see who has access to this project, and the group of people that can access the project depend on who you share your project with. So you can share your project by clicking on this icon, writing the username of the person you're interested in sharing the project with. And of course, that person needs to have an account on this platform, and then you can grant them different kind of licenses. So you can allow them to reshare the model, or you can just when they get the model, they cannot share it with anybody else. You can also allow them to edit the model or just be viewers of the model. Yeah, what I'm going to show you now is this project, which is the Easter Nile river system project, which is being worked on by a number of people within Future Dams. And as you can see, we have 17 networks because we've been developing different variations of the model, and we kind of always try to keep some backup models when we make some modifications. So when you open a project, then you get another similar sort of window with your different versions of the model, and it's pretty easy to create a copy of the model. And here you will see something similar. So if you again, if you share a project with a group of people, it doesn't necessarily mean they have access to all models within that project. So for instance, here I've got a model that is shared with one other person, while I've got another model which is only private to me. Nobody else can see it. Even everyone that's part of that project cannot see it. You can share a model with any group of people. You can add the username here. Again, you can also customize what kind of licenses you want to provide them. It's as Julia mentioned in the beginning, PyWR is a Python library, and it's an open source library. So the source of PyWR is available in GitHub, and you can always go there and learn a little bit more about it. So here you have the page of PyWR. It's available online, so it's not like you're dealing with a black box. You can always see what's happening in the background. You can also download your model in a JSON format. That's a text format. And then you can use that format to run your model offline. Actually, if you have a little bit of knowledge of Python and have PyWR installed locally on your machine, you can also do that. So what I'm going to show you now is a version of the model that I've been working on with a colleague. I'm sitting here in Manchester, and he's in Addis Ababa in Ethiopia, and we rarely actually needed to communicate, by talking to agree on things. We had a few meetings where we agreed on who should work on which part of the model, and then things kind of continued, because once you're working on the same model network, you see each other's progress, and then you understand right away what's happening, and you check on each other's work. So what you see now is how a model looks like in this web interface. So this is the Easter Nile River system. It's a part of the Nile. river system. It is around 60% of the area of the Nile Basin. This is a pretty detailed and large model, so it includes more than 260 nodes. Over 150 nodes are in this model are inflow nodes, so it includes quite a detailed representation of water supplies and inflows. So all the green nodes that you see here, these are inflow nodes, and each of these nodes is populated with a time series of river flows. The blue triangles that you see here, these are reservoirs, and you can use them to simulate different kind of physical elements in the system. So for instance, this is Lake Tana in Ethiopia, and we are using a reservoir node to simulate that lake. You could also use a reservoir node to simulate a man-made reservoir. So for instance, there's this Osiris Reservoir, which is located in Sudan. And in that case, you've got a couple of other nodes that can be used with an a man-made reservoir, like adding a turbine node to calculate hydropower. This type of node here, this is a control node, and this is where we normally add our system operating rules. So there was a question about whether you can add operational policies or not. Yes, you can. So for instance, this Osiris Dam here, if you double click on this node, you can see there are some release values, and this is a generic operating rule, which has a relationship between the proportion of storage in a reservoir and how much water should be released at each time step. So that's a dynamic operating rule. That's a very simple operating rule, and in a bit I'm going to show you a little bit some more complex and advanced operating rules that are enabled by the flexibility of this web interface. So this model now, as you see, this version contains two scenarios. So so these scenarios can be seen here. A baseline scenario, and that's the baseline system as of today or perhaps last year. So it's a baseline model, the historical model. And then we've got another version of the model, another scenario of the model with a new dam activated, which is it's called the Grand Ethiopian Renaissance Dam. It's under development in Ethiopia. You probably have heard of it. So we have two scenarios. So when you have a model, you can create different scenarios, and a scenario is just a variation of the physical characteristics of the same model. So we have a model with that dam activated, a model without the dam activated. And for instance, if we want to look at how the two scenarios perform, so for instance, if we go down to Egypt and look at the High Aswan Dam, which is one of the largest reservoirs in the world, and if we're interested, for example, to see how the water volume of this reservoir changes in the two scenarios, so you can just double click on that river element, which is a reservoir, go to the output section, that's the simulated volume, and if you click on the edit button next to it, it will take you to a window where you can see a tabular form of the simulated values. But this is we're just looking at one scenario in this case. If you plot the values, so here you can look at the water volume in that reservoir in the baseline, but you can also bring in the other scenario and then compare the two. Now I've created these two scenarios and run them just before I started this demo, just to save us some time. But you can add as many scenarios as you want and test as many system variations as you want. But this is just two scenarios, and each is run across one hydrologic scenario, but you can also have variation of hydrologic scenarios. Another thing I want to mention is some operating rules of river systems are quite complex and require a high level of flexibility. So for instance, if you're familiar with the Nile river system, there's a large swamp area here in the upstream part in South Sudan, simulating that water losses in that area is not straightforward, and there's no standard operating rule that can be used for that. Of course, PyWR contains quite a number of options for operating rules, and we call them parameters in PyWR. But but in this case, this was a different one. So we needed to build a custom way of simulating that part of the river system, which is not already in PyWR. Now, this web interface allows you to do that by giving you access to, you can actually through this interface write Python code that enables you to simulate unconventional processes in the system. Now, this code in the beginning might look a little bit intimidating, but it's pretty simple and pretty standard. The most important part of it is this equation, which calculates how much water should be lost depending on how much water is coming into the system. But it's a nonlinear equation, so it needed to be added here. The rest of the code is quite standard. So you write this code. This is more or less a generic code. And then if you go back to the model, you can then use it to simulate the processes, the losses at different points in the system. So here, for instance, this point here, the losses at this point are simulated using that operating group. The last thing that I wanted to mention is, and perhaps I already went over that, but when you have a model in the interface, you can always download it and run it offline. And perhaps some of the things that Julia mentioned, like linking a model to a whole economy model or a power system model, because since you have an access, since the model is open source and you have access to the source code, that provides you with endless flexibility in pretty much doing whatever you want to do, connecting the model to any other types of models. So, for example, my PhD is on linking this model to whole economy models, with the computable general equilibrium models, and that the economy models are written actually in a different programming language in GAMS. But again, once you have access to source code, you can do all sorts of things. That will be all from my side. Thank you.